We're starting a little late, but people come up to work out. Number 1, all Savannah had to do was plug in a number 5. Okay? And when the denominator didn't come out at 0, she was very happy. Right? So when it didn't come out to 0, she got 11 over 12. And it asked for a decimal, so she plugged it into her calculator instead. What is that decimal? Okay? So she got letter C. Number 2, she graphed in her calculator, which you can do, and see what that graph looks like. Zoom in, get more detail. You can see that.
Yay.
Can that natural log or any logs, not just the base, but also the expression? I think I've only told you about the base, but the expression also can't be negative. So if you have anything with a natural log x minus 3, you can simply set that to be greater than 0. Okay? And so x will be greater than 3. All right, number 3 and number 4. So for number 3, I said you can write the double angle identities, page 77, where it has the box of double angle identities. You can write those on your plate. Somebody want to come up and do number 3 and number 4? Tell you the answer.
Yeah.
Number 3.
I don't know how to do that.
I guess C. Okay.
Answer is C.
Oh, yes.
I don't know how to do that.
Well, if you're looking, what is sine 2a it's 2a in your book.
Yeah.
What does sine 2a equal?
Sine
2 times
cosine A cosine.
So that's the formula you have to use. That's when you need that formula for number 3, the double angle, 2 theta. Because it expects you to just multiply sine theta by 2 and get 2/3. Not the right answer. So you're given sine theta, correct?
Yes.
Okay, what happened to make my ink pen go away? But we don't know what cosine theta is. Question is, if you know sine theta, can you find cosine theta?
Yes.
What's a way to find that?
Pythagorean theorem to find the other number.
Okay, so using the Pythagorean theorem, we're probably looking at a right triangle, yes?
Yeah. 1 plus 9.
So I have a 1, because my theta is over here, opposite over hypotenuse is 1 and 3. Can you find the missing side length? And it becomes, you're going 9 minus 1. Because I'm using 1 squared plus b squared equals 3 squared. And we get something like the square root of 8. Can we leave it as the square root of 8? Is that as simple?
No.
There's nothing with square root of 8's in there. 2 on the square root of 2.
Wait.
Right? That's a side length. The square root of 8 is 2 on square root 2 root 2.
How'd you get that?
So I'm looking at the square root of 8. The square root of 8 is the square root of 4
yeah,
times the
right.
square root of 2. Sorry. So it's 2 root 2. So what's cosine theta? What's cosine? This is my theta. What's cosine theta?
2 root of the 2.
2 on the square root of 2 over 3.
So now we've plugged in everything to our formula. And we simply need to simplify, multiply across. So 2 times 1 times 2 is this. 4 times the square root of 2, 3, 1 times 3 times 3. I think it's letter C. Number 4. Do you want to graph number 4?
Yes. Oh, I already did.
Do you want to come up and graph it?
I think we do fast. We don't have time. I'm so sorry.
So my zeros are 0. Positive 1.
-5.
Negative 5.
+4.
Positive 4.
I hate these.
Why? They're so fun.
Graphing's my least favorite.
I'm sorry.
I'm so sorry.
My least favorite part is whenever we have to do math.
Okay, so the equation when you're plugging in something to the left of negative 5. We get a negative, a negative, a negative, and a negative. The 4 negative becomes a positive. So to the left, we have positive. If we plug in a -1, have a negative, a positive, then a negative, and that becomes negative. Right now, they will go on this pattern until I tell you otherwise. Positive, negative, positive, negative, positive. Just to save a little bit of time. And then it's a multiple choice question. Is f positive over the interval from -5 to 0?
No.
No, it's negative. F has a root at x equals -1.
What do you mean root?
Nope.
A 0, the roots of.
Oh.
A root is a 0. Does it have a 0 at -1?
No.
No. Is f positive over the interval from -infinity
Yes.
to -5?
Yeah.
Yes, we found one. It is letter C.
Wait, how did you determine where was positive or negative on the chart?
I plugged in numbers to the 2x parentheses x minus 1, x plus 5, x minus 4. We plugged in a -6. It doesn't matter. Plug in -10. Plug in negative
And then if
anything.
it's positive or negative.
That would be negative
And then you said it's just going to go back and forth for a while.
for a while.
Okay.
Until we start with squares.
Okay.
That'll do.
And how would you figure out the root?
The roots are the zeros. We're setting everything equal to 0. So 2x equals 0. What does x equal? There's a 0 there. X minus 1 equals 0. What does x equal?
1.
1. X plus 5 equals 0. X equals -5. X minus 4 equals 0. So x equals 4.
So,
So then those are my intervals. Now I'm going to look in between those dots.
okay, and then for the, so is C your answer?
Mhm.
How?
F is positive over the interval from
No,
-infinity.
Sorry. I was looking at B.
Ah,
I was looking at B. I tried to read it,
yeah. No, it doesn't. It has a
but
positive
yeah,
one.
you can keep explaining C.
Yeah. F is positive over the interval -infinity, because here's positive. It's up here somewhere. From -infinity to -5, it's going to be positive. It also would be positive over 0 to 1. Or from 4 to positive infinity. Okay.
And then you said for the spaces where you decided if it was negative or positive, you just put in
I'm-
a random number.
Random number between -5 and -1
Okay.
into that equation and determine whether it's positive or negative. Number 5. Inverse functions. Now, the issue is they did them all for you in your book. Every single one of them. Okay? If you have to go back to the original function, do that. There's some in the room right now. Yes, ma'am.
I just get confused on whenever we're flipping the curves and which way they're supposed to be.
Okay. Can I give you a hint? We will. Okay, so sine curve. It's going to do this along the x-axis forever. Yes? The inverse will do that same thing along the
So
y-axis.
I can just flip my paper and draw the curve.
Technically, yes. Alright, so sine. Where is it a one-to-one function?
From -pi over 2 to pi over 2.
-pi over 2 to a positive pi over 2. It's going to go like this like this. -1 to +1. And turn around with the graph, it only gives you part of that. But you know if you keep going to the right, it's no longer 1-to-1. Okay? So you have 3 points. Okay? All we're going to do is flip those 3 points. Okay, let me go back to this. This is y equals sine x. So when we want to graph y equals an inverse sine, okay, instead of being at pi/2, 1, I'm going to be at 1 pi/2. Okay? What you've put on your x-axis, original, will go on your y-axis on the inverse. And same thing, whatever was on your y-axis will go on your x-axis. We can talk about domain and range. The domain of the original will be the range of the inverse. The range of the original will be the domain of the inverse. So we have a point down here where it was -pi/2, -1. It's going to be -1, -pi/2. And we can't forget 0, 0. Okay? And I get Ryan's question every day of the week. Which way does it go? Because it kind of just looks like it could be a straight line. Okay? Where this one's going to go along the x-axis, this one's going to go, and sometimes I will go, oh yeah, that's the direction it's going to go. Okay? Then it's going to go this, and it can go this way. Okay? So I flipped it to go that way, flipped it to go this way. The little dash lines are not there. So we would just keep going that way. Ultimately, if you draw a straight line and you have your points labeled correctly, you will get credit.
Wait, will be right completely?
You have these points labeled. 1 pi/2, -1, -pi/2. I will be a happy person.
Yay.
Wait, I'm sorry, say it again.
If you have the points correctly. So 1 pi/2 on the blue graph.
It's okay.
What it is I need you to label things. End of story. I need you to label things. Do we need to do cosine?
Oh, yes.
Yes, please do cosine.
So,
Can I go on to the next
it
one?
looks different.
Yes.
It does look different because cosine is not 1-to-1 between -pi/2 and pi/2. You actually see that whole graph in the back. So cosine is positive or a 1-to-1 function from 0 to pi. So you have the point 0, 1. Oh, what's this point right here? Pi/2, comma, 0. And then over down here, you have pi/1. So if you can label those 3 points, this is y equals cosine x. So when I go to draw the y equals inverse cosine, ooh, I'm still in a black marker and I didn't mean to be. Inverse cosine. So I'm going to take the point 0, 1 and turn it into 1, 0.
Oh, it should be pi -1.
Ah, it's negative, yep. Thank you. And then pi/2, 0, is going to turn into what? 0 pi/2. There's a point there. And then next, or last, what's this last point down here? Pi -1 will become -1 and pi. Okay, still not a straight line. It's going to go this way because it would continue because it would continue. And they're all gonna kind of look like straight lines.
If I draw it really like straight line, but it's actually not straight line.
If you give me labels, label your points, then you will be okay.
Thank you.
You're welcome. Next. Oh, tangent. What does the graph of tangent look like? It is weird. You can graph it in your calculator. What's tan 0?
0.
0. Tan 0 is 0. But what happens at 90 degrees, Molly?
There's an asymptote.
There's an asymptote.
So the asymptote's gonna be
Is there another asymptote at negative pi over 2?
Yes.
So you're going to have that one. So in between those two asymptotes will be a one-to-one function. Now, the issue is we've had 3 points every time. What is tangent of 45 degrees? That's halfway in there.
1.
It is 1. I would love to see that point. What is tan negative 45 degrees? Negative 1. This will go here, go up, go back through that, and go down. If you need, if you see it, to have a inverse function. Whatever was on your x-axis is going to go on your y-axis. So we're going to go, well, we can go up to the point 0, 0. Then we went up, pi over 4, 1, so we're going to go to
1 pi over 4.
1 pi over 4. That's 1 pi over 4. Can we go to negative pi over 4? And we were at negative 1, so we need to go to negative 1, negative pi over 4. I just need to know which direction it's going to go. Should I label my asymptotes? Will there still be
Yeah.
asymptotes at pi over 2? And they're just going to be horizontal. And negative pi over 2. Oh, really not good straight lines. And it's just going to go down towards that. It's really not near that big. Whew. You gotta go fast now.
Okay.
I have no idea.
Can we
Can we
make
do
sure
like
we do 8?
8? Yes.
8.
8 was hard.
Okay.
Eight was
Number
the one
6.
I was mega confused.
Can we just tell answers?
Oh, yeah.
Number 6. M or L. L equals 516. M is 127.
But
Yes.
516.
516 and 127.
Okay.
Number 7 is 8x.
Oh, yeah.
And then let's look at number 8.
Wait, I'm sorry. Is it the sum of 2? Is that multiply?
Wait, what'd you say?
Sum is addition.
127?
Then what is multiply?
Product.
What is
127
what is division?
the quotient.
Quotient.
T Q-U-O
T-I-O-N.
D-A-N-T.
What is minus?
The difference.
Difference. C. So complicated.
8. Approximate the solution of 7 raised to the 3x minus 2 equals 13. Raised to the x plus 1. You had a homework problem that was very, very, very similar to this. Okay? Anytime you have variables in exponents,
Can you do the
we will always do logs. Most of the time. Unless you can write them in exponents. Could we write this is 2 to the something, 2 to the something? No. 7 and 13, they're prime numbers. So if you do log, or natural log, you technically could do either one, of 7 raised to the 3x minus 2. And log of 13 to the x plus 1. What happens when you do logs and you have
You
exponents?
can put the exponent in the front. So 3x minus 2 log 7 equals.
And I probably need these in parentheses. Log 13.
Yes.
Yes. Then, log 7 is just a number.
So
We're going to distribute to each thing.
that's how we do it in.
So you have 3x log 7 minus 2 log 7 equals x log 13 plus log 13. There's x's on both sides of the equation that I need to get together. So how are we going to get our x's together?
2x log 7 minus x log 13.
Okay,
Do you just
But-
subtract them?
the issue is there's a 3 and a log 7. Those are all numbers. But I do definitely want to subtract x log 13 from the left side or from the right side and from the left side.
And then you go ahead and add
And then we can go ahead and add.
the 2 log 7.
So those are canceled. If I add 2 log 7, add 2 log 7 to both sides. What are we left with? Because the 3x and the x we can't simplify like that.
That's 2 log.
It's 3x log 7 minus x log 13 equals log 13 plus 2 log 7. Now the deal is there's a factor of x still in both of these terms on the left. Can I factor it out? So if I factor out an x, what's left? 3 log 7 minus log 13, which is just a number. Equals log 13 plus 2 log 7. And the fact that this one just wants an approximation to 3 decimal places, we don't have to worry about simplifying. Which I still have to get x by itself. How do I get x by itself?
Will it be like
Divide.
Divide by x 3 log 7.
I gotta divide by all of that. 3 log 7. I think so. And then you're gonna plug all of this in your calculator, and you get a decimal. That's 1.973.
Well, you want us to leave it in like the terms of log, or do we have to?
When it says approximate to 3 decimal places, plug it in your calculator.
What'd you get? 1.9?
1.973.
I need your help.
Can I write up your answers for 9? Number 9, your wrist rewriting. So you've got, let's make sure I wrote that down right. Yeah. Natural log x. There's number 9. A and B didn't want you to do anything else.
Oh wait, we just had to leave it as that.
Cause
If
I,
you-
s- like, I CERN, doesn't it, you're supposed to solve in terms of ln x.
Natural log x and natural log y.
So wouldn't it, you have to, it's two answers for that, right? Because you have to solve for natural log x and then solve
Did it
for
say solve for? It says
well,
right.
Well, yeah, right
In terms of this and this.
I thought that meant solve for like right in terms of two separate things. So I mean, I have that at some point in mind. I just went even further. So
How did you write it?
Well, I mean, I got there out of, I was there and then I just went further. So it's like ln x equals negative 6 ln y.
But you don't have an
divided by-
equal sign anywhere in what you were given. You just added it. What did you? You took it to another side and you don't know what it is.
Well, I had that at a point, so that's what matters.
Okay.
And then I just decided to go further because that was unclear in my opinion.
Okay.
How do you put in
Just a lot of work.
I almost did that, but then you just said it equal to 0.
So is that for the bracket right before three?
I would put yes.
Okay.
Divided by, and then I would put all that. Yep, it's because it wasn't in parentheses, that second piece.
How did you get 7 and 10?
10, absolute values. When you have an absolute value of x minus 3 less than 0.5.
Oh,
Absolute, what?
so then you're gonna do 0.5, but then you're also gonna do.
Yes. Sure. 3 greater than negative 0.5. Okay, so you're gonna have two different equations. With absolute value, you'll have the positive regular one, then you'll have the negative one. And you simply solve. Add 3 to both sides. X is less than 3.5. Add 3 to both sides. X is greater than 2.5. Two different equations.
I'm confused.
What does absolute value mean?
Always positive.
Whatever comes out
Oh, I got it.
has to be positive. But what is inside? Can the inside be negative?
Yes. So it can be.
It can be negative.
But it's just going to turn to positive.
Ultimately, when you go to the negative side, it means the negative of x minus 3 is still less than 0.5. Okay? But what happens when you divide by a negative 1? You flip the sign, and that becomes a negative.
Gotcha, because everything else cancels out.
Okay?
Okay.
Oh, that's just, I keep writing it wrong.
Number 11. Did you remember to plug in for cosine squared sine? 1 minus sine squared. All right. Can I go to number 11 on another page? Did you get pi over 2 as an answer for number 11?
That's the only answer.
That is the only answer because it was sine x equals 1.
Wait, which one?
Number 11.
What's the answer of the
Oh. Can I go to the next page?
Okay.
So number 11, you get sine x equals 1. Did anybody have any trouble getting to that?
Sine
X has to be pi over 2. Between 0 and 2 pi,
Wait,
when is sine 1?
how did you know sine x?
As we solve the equation.
What?
Did you start out with 1 minus sine squared theta?
Exactly.
Plus 2 sine x minus 2 equals 0.
Oh, I remember.
Okay? And then last but not least, because I think we're done, number 12, graph this. It should be shifted up 3 units, 2, 3, and it should be a parabola that comes down and goes up and comes up like that. I need labels. Not really good. It's at 8. What's a negative 2, 3? And I think it was a positive 2, 3. This point right here is 8. Those are important labels to have. Did it go up to 4? Why did it go up to 4? Because the vertical shift should have been 3.
Well, if you plug in 2, because it's 2, so it'd be 2 squared. So it's 2, so it's 4 minus 5, which is negative 1.
Yeah, I need to finish mine.
Yeah. That would be that.
Make sure to draw a happy sign before you log off.
You think I should?
Except double punch.
Yes.
It would be 4 because if you plug 2 into the equation, so 2 squared is 4 minus 5, which is negative
Happy
1.
sign
Then it would be 1 plus
before
3.
you log off.
Right?
Oh, I know.
That makes sense, right?
You're gonna make me do it. X squared minus 5. What does x squared minus 5 look like?
A parabola.
It's a parabola. If I go over, I mean, if it's just a parabola, it should be at 1, 1. Okay? Then when I do a negative 5, I shift the entire thing down 5 units.
Yes.
Okay? So it should be here. It should be over 1, up 1.
It's not about being afraid.
I mean, I don't know that they ended right exactly at 2. I just
It's
guesstimated
about
that.
them.
But they're
Then
right.
becoming
Exactly.
I just know whenever you plug in 2.
I'm not worried
But
about
it
it.
could be-
About them.
The points where it flips, like this to up to here,
I'm reading this book
these
on how to
points
do it,
have to shift to 3.
So am I.
and I disagree with some.
Yeah.
Why doesn't it work?
And this one has to go up 5 units.
A lot of the things.
Because I don't know that it's exactly 2.
Is it
What's-
black
you wanna
with
look
the
at their
blue
answers?
cover?
Is it- yeah,
I
it's
just guesstimated that it went over to 2.
I don't-
It's kind of skinny.
I just
but
didn't
better
see
than
that.
big.
Yeah,
Yeah.
Exactly what the
And it has like guidelines, like points.
Yes,
Then it's
I-
it's not like a story.
Right.
Yeah. It's a
So
big book.
Yes.
3,
Oh,
right?
They're great. I thought
It
what,
has to
what
go
I
up
really
to
liked was like
Then how come when I
only
plug
where
it in, it doesn't do that?
exercise.
I don't know that answer.
Anything formula.
I just know that these points have to be at 3, and this has to be at 8.
Casual business setting,
When I plug it in, it should give me the right answer.
Did you plug in the absolute values
Yeah.
correctly?
I did it by hand.
My favorite is